Hello friends, welcome to another lesson. In our previous lesson, we introduced the concept of computational thinking, and we'll continue with our series of lessons. Remember, I'm a computer science teacher, and my objective is to demystify your most disturbing concepts in computer science. So let's ride on with our second lesson. Now, in this second lesson, we are going to be looking at problem solving. We started with computational thinking in the previous lesson, where we saw computational thinking, we saw the components of computational thinking, and we saw the importance of computational thinking with some revision questions. And we all agree that computational thinking is very important in the life of a computer science student, especially in problem solving. So in this lesson, my dear students, we are going to be looking at what is problem solving. And in our lesson, we are going to be having our lesson plan as usual. We are going to have an introduction, we have a lesson content, a practice exercise, and conclusion. And we have assignments, we have revision questions. So in our introduction, we'll start by defining what is problem solving. Problem solving is a fundamental skill in computer science involving the ability to formulate problems, think creatively about solutions, and express solutions clearly and accurately. I love the way this definition is formulated. Problem solving is all about your ability to formulate a problem, think creatively about its solution, and express that solution in a clear and accurate manner. So when we're talking about problem solving, we must know how to define a problem, we must know how to identify the solution to that problem, and then express the solution to that problem in a clear and accurate manner. When we have done all of this, then we can now actually say we are implementing problem solving. As we delve into problem solving within this field, it's essential to understand that it encompasses a systematic approach designed to address complex issues effectively through computational methods. So you see how the two now relate. So we are saying that it is important that before we are coming into problem solving, we should know that it involves a systematic approach designed to address issues effectively. Now, steps in problem solving. The first step in problem solving is to understand the problem. The first step is to understand the issue at hand. What kind of problem are we solving? Are we solving a mathematical problem? What kind of problem are we solving? So we need to understand the issue at hand. Now, this involves identifying what input is required, what output needs to be produced, and the constraints involved. The constraint means the limitations or the factors involved. Good understanding helps prevent time wastage on inaccurate approaches. So, understand the problem. First thing is to understand the issue at hand, and it involves identifying what input is required, what output needs to be produced, and the constraint involved. The second step towards computational problem solving, is planning a solution. Once you have a clear mastery of the problem, the first thing is to break it down. Divide the large problem into smaller, manageable parts. We are now implementing decomposition here. Choose strategies. Select appropriate algorithms and data structures that fit. We are going to see algorithms and data structures in our subsequent lessons. So it's important for us to understand this second step. That's why I'm repeating it. Break it down, divide the large problem into a smaller, manageable parts, choose a strategy, select an appropriate algorithm and data structures, because data structures will always show you how data is represented or stored within a computer system. Algorithms will give you the design of the solution to that problem. Okay, the third step in problem solving is now developing the algorithm. An algorithm is a series of steps for solving a problem or accomplishing some end, especially by a computer. So when we go to algorithm, we are going to see more of algorithms, but notice that it is a step in problem solving. So algorithm is not just the direct approach in problem solving, it is a step in problem solving. And an algorithm is the design to the solution of a problem. Now, developing effective algorithm requires understanding both brute force approaches as well as more refined strategies like divide and conquer or dynamic programming. These terminologies should not scare you. We are going to break down these terminologies when we are studying algorithms. So the algorithms can be developed using different formats depending on the approach you want to use to solve the problem. And this already tells us that there is going to be different types of algorithms for different circumstances. The fourth approach is implementation, which is coding. After developing the algorithm is a design to the problem. And implementation is also known as coding. What happens during coding? With pseudocode or an algorithm outlined already, the first thing is to choose an appropriate programming language. Remember, when we'll be studying algorithms, you will see that algorithms are independent of a programming language or an implementation language. I can design an algorithm and I use Python to implement. I can design an algorithm and I use like 5 different languages to implement that same algorithm. So the first thing is to choose an appropriate programming language. And it can either be C programming or Pascal programming, which is in your curriculum. Secondly, implement your solution incrementally. Test each component before moving on. It's good that we should have a summary of what implementation is all about. Choose an appropriate programming language. Maybe I choose C. Implement your solution incrementally, which means that you write from maybe declaring variables to defining functions and giving them procedures. Test each component, running the program to see if it works. It's about components. A software can have different modules or components that when put together gives the final solution. So all of this can be tested. And you need to also use a programming environment or an integrated development environment or a text editor to write your code. So we are going to show you how to do all of this. And the fifth step is testing and debugging. So after implementation, perform unit testing. Test individual components. So at our level, you mostly test code inside its IDE. You simply test if the program is running properly, if there is no error, because debugging is the process of identifying errors in your source code and solving them or correcting them. So you need to perform unit testing. You need to do system testing. Debugging involves identifying bugs, errors in code based on test results and fixing them accordingly. So at our level, students are expected to be able to do debugging or test a software if it's functioning properly. We can write a software, give you the source code, you open the source code, and you execute the program, and you come back to the source code and correct. That is the process of debugging. Now, the sixth step is evaluation, optimization. So once it is working correctly, review your code for efficiency improvements. So this is optimization, is making sure that the code continues to work at its best. And it is important in programming to have programs that are efficient. Optimize memory usage or execution speed. This is what we call runtime. So we are saying that optimization here is memory usage. What is the size of memory the program occupies at runtime? What is the speed it would take to execute? And all of this is without compromising reliability or maintainability of the code. So this is the essence of optimization. You can write a software to solve a particular problem that have just 10 lines of code. Somebody writes a similar solution to that problem and implements maybe 100 lines of code. You will notice that the person with the 100 lines of code will require maybe more memory usage at runtime, and maybe it might take a longer time. But the person who wrote just few lines of code but was able to solve that problem will have little memory usage and less time. And that is what we call optimization. So let's take note again about the key points of optimization. Review code, optimize memory and time. Tools and techniques. A variety of tools can aid problem solving in computer science. The first thing is using an integrated development environment. I mentioned already. You need to use integrated development environments as softwares that permit you as a software developer to develop softwares or write code. Examples we'll be using in our lessons will be CodeBlock, DevC. There's also Visual Studio Code. There are so many. And these IDEs make it easy and simplifies the code writing instead of writing from a text editor. So take note, integrated development environments are used as tools in problem solving. We also have version control systems such as Git. Professionals who are into software development use this. Even students in higher institutions use this to share their projects or share code or to commit their work in a collaborative environment. So that is to tell that these are tools that are used in problem solving. So in summary, problem solving in computer science isn't just about finding any solution. It's about finding the most efficient and suitable for current constraints. So problem solving in computer science is not just for example, how do I find the square root of a number? The most important thing is what is the most efficient and suitable way of getting to the square root of that number. So that is the most important aspects of problem solving. Emphasizing planning before coding can save significant amounts of time. This is what we say: you have to do analysis, you have to do design before you come to implementation. So emphasizing planning before coding can save significant amount of time. So for revision questions, my dear students, these are the sample questions we have shortlisted for you. Explain the term problem solving, describe the process of problem solving, describe a tool used for implementing the solution of a computer problem. When you must have answered all of these questions, then you will actually be able to evaluate your mastery of problem solving. In our next lesson, my dear students, we'll continue with a series of lessons. And thanks for watching. And remember, we are here to demystify your most disturbing concepts in computer science. See you in our next lesson.